ICEAS Conference 2024 now. Good morning. 2024 ICEAS. I'm a professor, SEOUL from Seoul National University. We'd like to thank everyone who attended in ICEAS 2024 despite your busy schedules. Before the event begins, I'll give you a brief introduction. The simultaneous interpretation will be provided. So if you need the service, please use the receiver on your desk. The Korean channel is 1. Channel 2 is English.
For English, it's channel 2. 본 행사의 개회식과
The keynote speech and opening ceremony of this event are currently being broadcast simultaneously online through the YouTube channel of the Appropriate Technology Society. Please turn off your mobile phones or change them into vibrate mode. Also, please note that eating and drinking is prohibited inside the event venue, so please cooperate so that the conference can be held smoothly. Now, let us begin the opening ceremony. First, we will listen to the opening speech by Professor Min-gi Bok of Seoul National University, the President of Society for Appropriate Technologies. Please welcome him. Good morning. I'm Min-gi Bok, the President of the Appropriate Society for Appropriate Technology.
Good afternoon and good evening to those of you who are attending through Zoom. Distinguished guest, Mrs. Mihoko Kumamoto from United Nations Institute for Training and Research, and Dr. Sang-hyuk Lee, the President of National Institute of Green Technology, and Professor Jae-young Kim, the Vice President of Seoul National University, and ladies and gentlemen. I'm Ki Bong-min, President of the Academic Society for Appropriate Technology. On behalf of the Academic Society for Appropriate Technology, I would like to extend my warmest welcome to all of you who are participating in the International Conference on Energy, Aquatech and Sustainability, ICEAS 2024. The ICEAS series began 7 years ago in Arusha, Tanzania, and I'm extremely proud that this series has continued, celebrating its 7th event this year, even surviving the COVID era. The goal of ICEAS 2024 is to discuss and find solutions to the issues of energy, water, and sustainability, which are grand global challenges we face today. In particular, the Academic Society for Appropriate Technology is committed to offering engineering solutions in more affordable way and energy efficient way and environmentally sound ways in close collaboration with local communities. Some say that appropriate technology is low-tech, using only simple technology. However, this is either far from the truth or only half the truth. Appropriate technology is now broadly defined to include a spectrum of efforts that place emphasis on the benefit of the people and the environment using the advanced technology that have now become more readily available. Digitalization, renewable energy, and business planning are all crucial concepts in appropriate technology. In this sense, I would like to claim that the ICEAS series is paving a new way to redefine modern appropriate technology. More than 70 papers being presented at this conference are the results of such efforts, and I would like to especially express my appreciation to those of you who are presenting your valuable findings. Finally, I would like to express my sincere gratitude to the organizing committee members who put all their efforts into this conference. In particular, I would like to extend my sincere thanks to the organizing committee chair, Dr. Sakhan Lee of KIST, and co-chair Professor Seonyang Lee of Hanyang University. Thank you very much for your efforts. Once again, I warmly welcome you, and I hope you have a wonderful experience. Thank you very much. 감사합니다.
좋은 말씀 감사드립니다.
We will continue. Dr. Sung-hyun Lee will have, and the congratulatory speech will be given.
Nice to meet you, everyone. I'm one of the preparation committee chairpersons, Isokhan. Let me give you a simple welcoming remark. Thanks for coming, you all, despite this hot weather. And Kumamoto Miyoko, director, thank you for coming all the way from Switzerland. And Vice President Kim Jae-young and Mr. Kim Yong-ho and the President of Academic Society for Appropriate Technology. Thank you for coming, you all, and all our presenters and all relevant participants here. Thank you so much for coming. I hope this will be an opportunity for you to share your expertise and experiences. And this time would serve as a great opportunity for us to move forward with this technology. Thank you.
I'm Seonyang Lee from Hanyang University. I am honored to take part of this ICEAS conference with Dr. Sakhan Lee. And I welcome you all from all over the world to attend this ICEAS conference. And just want you to know that this is the best place to be at this hot, humid weather. And I hope that you would enjoy this conference today and tomorrow. Thank you.
감사합니다.
네, 두 분 좋은 말씀 감사드립니다.
Thank you for your wonderful welcome remarks. Next, let me invite Vice President of Seoul University, Mr. Kim Jae-young. Please give him a big round of applause.
Vice President of Seoul National University didn't know that I had a simultaneous translation service available, so I didn't know. So I wrote them in English. So anyway, I'll just read. 내외 귀빈 여러분,
you all to the conference ICEAS 2024 on behalf of Seoul National University. It is a privilege to meet and address such a distinguished gathering of scholars, researchers, and professionals from around the world. The ICEAS 2024 conference is a testament to accumulate knowledge and the first innovation in the field of appropriate technology. This event provides a unique platform for the exchange of ideas, sharing experience, and forging collaborations that will drive future advancements and address global challenges. Climate, energy, water, and sustainability are huge global challenges facing us today. And we know that the Society for appropriate technologies, committed to working closely with local people and the developing countries to engineering solutions. As I am also interested personally in the development and application of appropriate technologies, I'm also a member of the Academic Society of Appropriate Technology. The vision of Seoul National University is the community of knowledge leading the future. On behalf of Seoul National University, I'm so proud to support the ICEAS 2024, of which the theme resonates deeply with SNU staff. I extend my sincere thanks and congratulations to the ICEAS 2024 organizers. Their dedication ensures that ICEAS 2024 will be an unforgettable experience filled with insightful presentations, simulating discussions, and valuable networking opportunities. To all participants, I encourage you to take full advantage of this opportunity to share your expertise, learn from your peers, and explore potential collaborations. Your contributions are crucial in driving the progress and innovation that our world urgently needs. We know that if we want to go far, we have to go together. Once again, welcome to ICEAS 2024. I wish you all this productive and rewarding conference and enjoy wonderful time at the SNU campus. Thank you very much.
네, 좋은 말씀 감사드립니다.
Thank you so much for your wonderful comment. Thank you for coming to attend ICEAS 2024 out of your busy schedule. Before the plenary session, we would like to have group photo. So all the participants, please come forward to the stage for this group photo, please.
네,
Please take your seat. Next, the keynote lecture will be followed. The keynote lecture will be given by three speakers. We would like to invite Professor Sun-Young Lee, Co-Organizing Committee Chair, to the keynote lecture.
Great guest from Korea and Swiss, and so to introduce a great talk today. The first plenary speaker is Director Miyoko Kumamoto from UNITAR. So let me introduce a little bit about her. And Ms. Miyoko Kumamoto has nearly 30 years of professional experience in the development cooperation field and has been with the United Nations for more than 20 years. Ms. Kumamoto earned her master's in economic development from Columbia University, and she joined the United Nations Development Program as a junior professor officer in 2001 in UNDP Vietnam Country Office. And then she moved to UNDP headquarters in New York in 2003. From 2012, Ms. Kumamoto served UNDP Indonesia as a senior advisor. And she joined the UNITAR in 2014 as head of UNITAR Hiroshima office, and she was promoted to director of the office in June 2018. And from 2019, the Hiroshima office became part of the new UNITAR division of the Prosperity, which also comprised of public finance and trade program unit in Geneva. And Ms. Kumamoto, Director Kumamoto, was appointed director of the division. And she's concurrently representing the Hiroshima office until the appointment of Ms. Chisa Mikami as head of the Hiroshima office in November 2023. And she's continuing to serve UNITAR as a director of the Division for Prosperity. So we are very honored to have her as a plenary speaker. Please give a big applause for her talk. Thank you.
Hello, everyone. Okay, great. Thank you. 안녕하세요. Thank you very much for your kind introduction. My name is Mihoko Kumamoto. I am Director of UNITA's Division for Prosperity. This is my second time to come to Seoul this year, and it's always very exciting, and I really enjoy coming to South Korea every single time. So thank you very much for your kind invitation to this conference. Now, I am hoping to spend the next 30 minutes to talk about UNITA and what UNITA has been doing in different parts of the world. And I have to say that I am not an engineer. And I know that this conference focuses on energy, water resources, and the technical engineering field. But I have to warn you, I am not an engineer. However, what I'm hoping to do today is to explain to you what the United Nations, and particularly my current organization, UNITA, has been doing. And as Dr. Kim just mentioned, for the UN, we also say a lot. If we want to go far, we have to go together. So we have been putting lots of emphasis on partnership. Partnership with academic institutions like Seoul National University or universities around the world, and also private sector as well, to be able to come up with innovative solutions, because global issues we have faced right now are enormous and extensive, very complicated. Therefore, partnership is extremely important. It's central to our work. So I'm hoping my presentation today will inspire some thoughts. And I'll try my best to, giving my presentation, like sort of explain where the UN and academic institutions could collaborate more. And I really hope after my presentation, we have opportunities to start discussing how the UN and the academic institution could collaborate more. So with that, I would like to start my presentation. Now, I also have to warn you, I have bad eyes, so I might have to get close to here to be able to see my slide. So, okay, all right. So very, very quickly, introduction of my organization. I work for UNITA. It stands for United Nations Institute for Training and Research. So we are dedicated training arm of the United Nations. Now, you might already know the UN system is enormous, consisting of more than 40 UN agencies, including, for example, I'm sure many of you know UNICEF, or UNEP, or UNDP, etc., UNIDO, etc., etc., etc. So the list goes on and on. Now, within the UN, there are two dedicated training arms. One is called UNSCC, United Nations Staff College, and the UNITA. Staff College mainly focuses on the training of UN officers, while the UNITA, our organization, focuses on the training of government representatives or representatives from UN member states, including government officials or private sector, sometimes academic representative from the academic institutions as well, and civil society organization, etc., etc. So we provide training, learning solutions to people outside the UN, adults mostly, so youth and adults. So generally between the age of 19, sometimes a bit younger, 18 to older. So in that sense, what UNITA does, and universities like Seoul National University, for example, are doing are quite similar. We give knowledge solutions to adults. Now, location. So UNITA's headquarters are Geneva in Switzerland, and that's where I am based. Other than that, we have office in Hiroshima, Bonn in Germany. This Bonn office focuses a lot on environmental issues, particularly climate change. And I'm sure you know why, because UNFCCC, United Nations Framework Convention on Climate Change, is located, the secretariat is located in Bonn. And we also have an office in New York, of course. And we also have these network affiliated organizations called SEOUL. And SEOUL they are often universities or research organizations, and have agreement with UNITA, so we have affiliated relationships. Now we have a SEOUL office in Jeju, actually, Jeju SEOUL Center. Now, quickly, history of UNITA. So UNITA was established in 60 years ago. So this year marks 61st anniversary of UNITA. Now, the number of beneficiaries, so in 2022, thanks to digital technologies, we have been able to reach out to almost 400,000 people per year. So that's our reach capacity to reach out. Okay, so very, very quickly. So we provide training services to people, government officials, or UN member states around the world. Now, when you look at this graph, 36%, so the highest participants come from Asian countries, followed by Latin America and the Caribbean, and Africa, Europe, North America, and finally, the Middle East. And the partnership, so once again, if we want to go far, we have to go together. So once again, partnership is central to everything we do. So we work closely with governments and academic institutions, 24%. So once again, we collaborate a lot with universities in many different forms. For example, sometimes UNITA works with an academic institution to design and implement degree programs. We have multiple joint master program or advanced certificate programs, so-called short courses as well. Certificate programs, non-certificate programs as well on different topics, any topic related to the SDGs, Sustainable Development Goals. There are also various study tours jointly organized by UNITA and academic institution, study tour to come to Geneva, for example, so that students could experience what it's like to work at the UN, or study tour to New York, or a different part of the world, sometimes study tour to the field. So that's another form of collaboration. Okay, very, very quickly, this list is not exhaustive. So there are many areas where we have been working, but long and short, UNITA works on all aspects of SDGs. There are, as you know, there are 17 SDG goals. So, and these 17 SDG goals can be grouped into so-called 5 Ps: prosperity, people, planet, peace, and partnership. So UNITA is organized around these Ps. So that's why I am from Division for Prosperity. And you know, like many people have told me when they saw my business card and title, wow, you are from Division for Prosperity. It's you know, this prosperity, it's enormous, it's a big topic. And we are striving, we are trying our best to help achieve prosperity, but still, as you know, it's a huge challenge. Much more efforts need to be made, and much more need to be done. Now, coming back to where we work very, very quickly, entrepreneurship, startup. So this is also an area where we collaborate a lot with academic institutions. Like, for example, we have collaborated with Stanford University in the US, or we have been working closely with Geneva, University of Geneva, Geneva Graduate Institute, so on and so forth. Digital upskilling and reskilling, this is an area that is that's becoming very, very popular. Youth and women's empowerment. Youth empowerment particularly, we collaborate a lot with academic institutions. We organize hackathons so that students learn about different, they pick one big challenge and then collaborate with a private company and also UN agency and try to come up with creative, innovative solution and pitch their idea in front of the audience. That kind of hackathon we have been doing a lot. Trading finance, combating financial crimes, anti-money laundering, we are doing this in Colombia, Colombia, Bogota. Nuclear disarmament and non-proliferation, this is mainly out of our Hiroshima office, and also peace building prevention side, and also PKO side, peacekeeping, and peacemaking side. And peace from the lens of women, peace and security is also another important field. And also moving to planet area, and I'm sure many of you are probably working in this field a lot. So chemical waste management, climate change, and also green economy, fair economy, transformation. So any area related to planet issue. And then other issues, road safety, health, diplomatic training, satellite image and analysis, cultural heritage. So here you see what UNITA is doing a lot. Now, one thing I would like to highlight here is UNITA, we are expert in training and adult learning methodology. When it comes to thematic areas, we have good knowledge and understanding, but we are not like academic institutions that strive for cutting-edge knowledge. So what we have been trying to do is to form a partnership with academic institution or subject matter expert, and we come in as expert of adult learning methodology and instructional design so that we co-create learning materials and deliver learning materials to our clients who are UN member states. Okay, I'm just checking time. So I've been talking a lot, and sometimes it's easy to see video. So it's a bit of a promotional video, but introduces some of our activities on digital upskilling and reskilling. So I would like to show this video now. Is that okay? Yeah, thank you.
The World Economic Forum has estimated that 9 in every 10 jobs will require digital skills in the future. A 2021 report by the International Telecommunication Union, ITU, states that 40% of individuals in 40% of countries surveyed reported carrying out an activity that requires basic digital skills, illustrating the need for more people to acquire such skills.
While the process of digitalization has been a catalyst for development, it has also created many problems. Some of these problems relate to exacerbating existing inequalities for the most vulnerable groups.
Vulnerable sections of society, such as women and youth, are particularly affected by this. For example, UNESCO reports that globally, women and girls are 25% less likely than men to know how to leverage digital technology. Addressing these inequalities is pivotal in enhancing opportunities to fully participate in a digital society. UNITA, in partnership with the government and people of Japan, has been working towards reducing inequalities and ensuring that no one is left behind, which is integral to providing equal access to opportunities and achieving the Sustainable Development Goals.
Our transition to the digital space has helped us exponentially expand our learners and beneficiaries. We design and deliver innovative training to address the needs of individuals, of organizations and institutions.
In the past few years, over 1,900 participants in Afghanistan, Iraq and the Sahel region have benefited from this partnership through the Digital Reskilling and Upskilling Programme. The programme trains participants in digital literacy, application development, data programming and coding, and artificial intelligence and cybersecurity.
I joined UNITA in the program of empowerment of Afghan women through digital reskilling in 2021. And later, in 2022, I got an opportunity to be a mentor and coach for other Afghan women.
The UNITAR training equipped me with a range of valuable skills and practical knowledge, including market analysis, financial management, and marketing strategies.
Cette formation a été d'un grand apport en ce qui concerne ma perception, en ce qui concerne la question des genres, la question de l'acceptation, la question de l'inclusion en milieu socio-professionnel.
That present them with unique opportunities to get to know people from different backgrounds, and that's extremely important to promote peace, sustainable peace.
I founded a non-profit organization, She Codes Too, in 2020 after attending the Empowering Social Entrepreneur and Youth Leaders for Iraq program. She Codes Too provides safe and supportive environment for Iraqi women to learn computer programming and to pursue career in tech sector.
Après notre formation, j'ai eu à former des personnes aussi bien en présentiel qu'en ligne dans le domaine du e-learning, de l'éducation inclusive, de l'éducation en situation d'urgence et aussi sur des questions de l'intégration du numérique dans les activités du quotidien dans ma communauté.
Such an amazing and incredible opportunity that Afghan women can actually learn from online, from distance, which means a lot to us.
The role that Hiroshima could play for the world is extremely important and relevant, particularly right now. Hiroshima is symbol of peace, symbol of prosperity.
And we really appreciate the program. We really appreciate all of the efforts the people of Japan, the government of Japan, and the participant of UNITAR has provided for us. Thank you.
I would like to express my deepest gratitude to the government of Japan for their supporting and funding UNITAR program.
Kono kikai wa arigatou gozaimasu.
Thank you. So, okay, here we go. Yeah, this video was produced for the G7 Hiroshima Summit last year. So we focused on projects funded by the government of Japan. But we have been cooperating with many governments, including the US and also Swiss and many other countries. So again, we partner and we support. Now, as you see, the role of UNITA or the UN in general is there are, let's say, there are some high-tech solutions produced by academic institutions like yours. Now, our role is to apply and make it relevant to context in developing countries, and to support countries such as Afghanistan or Iraq or South Sudan, where the situation is harsh and difficult. So that's what we do. We bridge. We come in as a bridge between academic institutions or research institutions and the national government, and deliver that to people on the ground, so that their lives become easier and better for them. So that's what we do. Now, very quickly, I would like to show some case studies. I will not have enough time to explain too much details, but very, very quickly. So this one is entrepreneurship training for Afghan women and youth, which we have been implementing for quite a long time. Here, it covers only 2 cycles, but before 2021 as well, we have been supporting the country for many years. If we look at these years, from 2021 to 2023, we have trained about 750 men and women. It's both online and also in-person training. Yep, that says. And some results, so program rated, like we also do research survey to find out how participants find the training program. I believe many of you might be wondering how we have been implementing this project in Afghanistan, which has been facing lots of challenges. Luckily, we have extensive network on the ground. We have been active in Afghanistan since 2003. Therefore, we have a large number of alumni on the ground. Many of them have actually left the country, but we have a good number of people who have stayed in Afghanistan. So we have been working with them very closely. We have been also working with a university, local university in Afghanistan. It's a women's university. So our in-person training is conducted by the local women's university. So once again, partnership has been key to be able to implement this project successfully. And very quickly, this is another example. This is women's leadership training in the area of disaster risk reduction. Here, small, so-called SEEDs, small island developing countries, developing states in the Pacific, are many of our participants come from these SEEDs countries. And as you saw in the video, you see lots of inequality in any field. So for example, in terms of digital upskilling and reskilling, you saw in the video, more women have been facing difficulties when it comes to access to training. And likewise, disaster risk reduction too, when you look at statistics, more women have become victims of various forms or types of natural disasters, tsunami, earthquake, because of many different reasons, lack of information, lack of financial resources, etc., etc. So this training program, our goal is to empower women, to give them knowledge and information so that they'll be able to act as a local leader to promote disaster risk reduction. And once again, this training program, we have been working closely with various universities who have latest technologies and information. Very quickly, our training approach, okay, I'm checking time, 8 more minutes. Okay, so this is, our routine. This is how we implement our training activity, or design and implement and monitor and evaluate training activities. Firstly, analyze, assess. So we start with so-called needs assessment to understand better what gaps are. So we do survey to understand, to assess the current level of knowledge and information of participants. And from there, we clearly decide what the target level after the training. And then based on that information, we design jointly with academic institutions, research organizations, or subject matter experts, and develop training materials. And once again, here comes UNITA's expertise. What kind of design we should do for effective learning, adult learning methodologies. So, it's like, for example, chunked learning, micro learning, because many of our participants are adults who have full-time job, and women in rural parts of the world who are multitasking constantly, so their time is extremely limited. Therefore, often our learning materials are chunked into small pieces so that whenever they get extra time, they'll be able to check quickly and acquire new information. And also, digital technologies. Some people have access to internet. However, some people don't have internet, or even if they do, not really high speed. So whenever we design training program, we have to take local context into consideration. Do they have sufficient internet access? What kind of speed? And depending on the situation, we go with high tech, or sometimes no, we go with different approach. And we implement, and then we evaluate. Evaluation is always a big challenge because of this attribution issue. For example, after training, someone get promotion or get a job. But is it because of the training, or is it because of some different factor, or is it combination of many different aspects? So this evaluation aspect is one of the biggest challenges for training organizations, training experts. Now, okay, challenges and opportunities. So these are my last slides. Once again, our goal, or the ultimate goal of the UN, is to leave no one behind. So when you look at the current world, there are huge inequalities everywhere. So how to close gaps, reduce inequality, that's our ultimate challenge. So very, very quickly, so SDGs, Sustainable Development Goals, as many of you know, it's a roadmap for sustainable future, sustainable prosperity, sustainable peace. As some of you may know, in July, so last month, well, actually every year, the UN organizes this international big conference called High-Level Political Forum in New York, where government representatives from all the UN member states, 193 member states, come together and discuss and assess the current achievement level towards SDGs. So last month, government representatives came to New York and assessed. Now, the news is not good, and it was not a surprise at all. When you look at 17 goals, under all these goals, there are 169 indicators, and only 17% of these indicators have been achieved. Only 17%, which is extremely, extremely low. So overall, when it comes to SDG achievement, the world is far off track. And the goal year of SDGs is 2030. So we have only 6 more years to go. So we really, really have to accelerate, bolster our efforts if we want to achieve SDGs. Now, when we focus on UNITA's activities, what kind of challenges we often face? Number one, infrastructure limitations. So I mentioned about internet access, that's one of the biggest challenges. And also, when we think about these developed countries, LDCs, for example, South Sudan, where infrastructure is extremely limited, road, for example, there are not many proper roads. So when it rains, it quickly becomes flooding, and it becomes extremely difficult to move from one place to another. So when there are workshops, in-person meetings, for many participants, it's very, very difficult to get to a meeting location. So that kind of a situation. And also security issue. When there is a meeting, is it safe, for example, female participants to come to a meeting location? So there are those infrastructure or security limits, and we have to find a way to go around it and make sure participants can join meeting safely. Internet access, produce engaging and contextualized materials. So once again, adults, they are busy. They are busy. And like whenever you sit in a meeting, like back of your head, you are constantly thinking, okay, how many emails have I already got? And you feel this urge to check your email. So, this is constant, conflicting demand for adults. So how to make sure we produce materials that are engaging and exciting and interesting. And also nowadays, it's not just lecture style is, of course, it's definitely one of the effective ways. However, peer-to-peer learning is also extremely important. And there are many different forms of learning. So making sure those are taken into consideration. Language barriers as well. Particularly for the UN, we go to many different countries. So making sure we use local language as much as possible. There are UN official languages, but there are many countries where those UN official languages are not spoken. So the language and evaluation attribution issue I have mentioned already. Okay, on the other hand, of course, there are always challenges and opportunities. So opportunity, so hackathons. So this is, I'm sure many of you have participated in hackathon style. So this hackathon style, it's very dynamic, interactive, and depending on how you design, you create an opportunity to interact with people from different sectors. Like for example, one hackathon we organize regularly is we invite representatives from academic institution and representative from the private sector and representative from the UN, and they form a team and spend a good chunk of time to think through a global issue and try to come up with new ways and then pitch idea. Informal, dynamic, engaging environment. So that's something we have been pushing more and more. Micro learning and also using high technology and also low technology. So, digital technologies, thanks to many engineers, including yourself and around the world, lots of technologies are coming out and lots of applications are coming out, and some are extremely useful and effective in rural areas in developing countries. So we are constantly looking into it, and now AI is becoming increasingly important. So a digital evolution. So for example, metaverse, AI, and virtual reality. Many people cannot afford or do not have time to travel. So for those people, virtual reality could be a useful way to experience. So we have been using these different ways. Okay, a bit over time, but lastly, once again, thank you so much. And again, the UN partnership is central, and partnership with the academic institution is extremely important. So I really look forward to having more conversation with all of you. Thank you.
Thank you.
감사합니다.
Thank you, Miyoko, for your great presentation. Because of time being, time constraint, we have to go on to next presenter. My script is in Korean, so I'm going to do this in Korean so that you can get the translation in English. 다음 기조 강연 발표분은
바랍니다. The next presenter is President Lee Sang-yeop of NIGT. He's been the president of NIGT for the past 10 years, and he was a head of the National Institute Energy Environment sector, and a chairperson or head of KAIST water source. And he's been leading key step carbon neutral technology development, and a member of the fourth Science Technology Establishment Plan. And he had several patents, and he was awarded by the Minister of Science here in Korea. And he's been one of the 100 excellent examples of the national research development sector. Please give him a big round big round of applause. Thank you so much for your great introduction. I'm Lee Sang-yeop of NIGT, and she said I've done a lot, but I'm sure most of you have done the same. I've been thinking about what to say, and I majored in water treatment. So I've heard a lot about appropriate technology. So whenever I heard the word appropriate technology, I came up with three words: 적정, 적당, 적절 in Korean. And 적정 means appropriate, 적당 means adequate, and 적절 means proper. So I've done a lot of research using Naver, Google, and ChatGPT. So I came to this conclusion that 적정 is appropriate, 적당 means adequate. But neighbor, I wanted to neighbor on other portal says the adequate. I thought suitable is right, but those sites said adequate. And 적절 is proper. But artificial intelligence says 적정 is appropriate, 적당 is adequate, and 적절 is appropriate. 적절 is proper. So I decided to follow the advice of AI, and I have come up with those three words. So this seminar, this conference is on appropriate technology. And many people think appropriate technology is equal to low technology. So whenever I heard appropriate technology, I thought it's somewhat good enough technology, something in between. So I'd like to share what I have thought of appropriate technology and what I have done as head of this institute, NIGT. As head of this institute, NIGT, I'd like to introduce my institute. I'd like to say thank you so much to the president of Academic Society for Appropriate Technology and vice president of Seoul University. And we have been working for the past 11 years. And our philosophy is green triangle philosophy. That's our philosophy. So Green Climate Fund, Global Green Growth Institute, and GTIT. I'm sure you're all familiar with those initials, names. So previously, we were called GTO, but we changed our name to NIGT. So green growth has been was the state philosophy in 2023, and it was issued by then president in 2013. So in order to achieve green growth, we need fund and technology and knowledge. So we started with this triangle on the left, but we had to adjust it. So GGGI became under the Ministry of Foreign Affairs. So the triangle philosophy of this triangle had to change. So now NIGT is inside the triangle, and we try to take good balance between the government institute and other private institute for this green technology. So we've been thinking about and looking for funds to support this triangle. That's what we've been doing. The unique thing of our institute is we don't have rep. So you can see that we are just a think tank, and we try to find connection between our institute and other institute and government fund. So we have Uri Bank, and in this triangle, we try to connect financial institute, government institute, and private institute like NIGT. So we are making good use of our resources and information to make all these connections, to connect, to develop policies to connect all them. So let me go back to this slide. So here, I'd like to give you an arrogant question. Appropriate technology, adequate technology, proper technology. Do you tell the difference between those three expressions? What's the difference? I have vague knowledge or understanding, but it's not clear for me. So far, appropriate technology. It was somewhat like adequate technology, and I can tell clearly what's adequate technology and proper technology. What's the difference? What's the clear definition of those three expressions? That's been my concern for long. So I thought that if a technology achieves its goal or purpose, then is appropriate technology. I thought. When a technology is developed, there must be a goal or purpose, and the goal of the technology is to achieve a certain aim. Disinfection. Let's take disinfection for example. So that's very important to prevent waterborne diseases. For advanced countries, technology for disinfection must meet certain regulations there in a country. But when it comes to appropriate technology, the word must is gone. That's been the approach we have been taken. So when we apply or have appropriate technology, we just meet the regulation. So appropriate technology for disinfection is to achieve a purpose. That's installation of disinfection processes. That's what we've been doing so far. But not must meet. Meet is the aim of our my institute, NIGT. So with this in mind, we have been making great contributions to underdeveloped countries. So now it's time for us to to pursue a change, a big shift of direction for our society. So around 2 years ago, Secretary General used global boiling, not global warming. And what is important about global warming is that how to reduce the CO2 level. Um, so the purpose of appropriate technology in the area of climate change is to reduce the amount of carbon emission.
So now, appropriate technology, adequate technology, and proper technology need to be distinguished. So appropriate, adequate, and proper are the terms that has to be used differently. When it comes to development of the technologies, so I wrote 3 sentences. These look very similar, looks the same. So proper tech, adequate tech, and proper technologies. So when you use two words, then it looks different. But if you add and making a sentence with the carbon neutral climate change responses, these look all the same. So these are in the field of confusion. So instead of the climate changes, it's more like an era of climate boiling. This is the era we have to reduce the carbon dioxide, and you have to make a new approach by using the right word. So how these two sentences can be distinguished? Ultimately, appropriate, adequate are different in terms of the efficiency. Appropriate, adequate, and proper technologies are different in terms of the nuance. In the climate change era, to effectively make a transition, how you reduce the carbon dioxide would be the key word. So in appropriate technologies, you could use the number 1, and adequate, you can use the unit 0.1, and proper technologies, you could use the number 0.01. So appropriate and proper technologies should be distinguished and should be considered the effectiveness. In terms of the efficiency, these 3 technologies are the criteria to make a distinction. As Professor Mingebok has said, it has to be focused on the situation of each country. And knowing the exact situation of the country will be very important. So 190 countries registered in the UN, you should understand the situation of each country to select appropriate, adequate, or proper technologies. So among these technologies, you have to use the exact use that will be the right direction of development. Knowing the situation and choosing among these 3 technologies is important. I put the word clearly, clear selection of the technologies based on the situation and the exact use of the technology will be the very important element in the era of boiling climate. Knowing, choosing, using are the flow to selectively use technologies and transit these technologies. And finally, each country will have to position these technologies as the best technologies. I think that is more recommendable way for choosing direction. So achieving the highest efficiency, solving the big social problems, and contribution of a true and real contribution will be the strategies in the time of climate change. To give you a conclusion, I just summarized it as 3 conclusions. In Korean, it is very easy. There's a word saying that knowing your enemy, then you will win every battle. If you know the enemy perfectly, you always win. That was the English version of this word. The reason I'm bringing this word is because, as I mentioned earlier, you have to understand the target country and understand the situation of that target company and the target country. And it will contribute to the developing countries. 190 countries registered in UN would have different circumstances. So based on the circumstances that the country is facing, you should consider a lot of things in terms of the appropriate technologies. The target company, the developing country, you have to understand the situation of that country so that you can find the right direction. I have been thinking about this word and then I created my own. If you know the status of country perfectly, appropriate technology is at its peak efficiently every time you use it. I used Google for translation and they give a very difficult term. So I just made my own English version. If you know the status of the country perfectly, appropriate technology is at its peak efficiently every time you use it. Long sentence. You have to understand the detailed information of the country so that the country can go further to the right direction. So to give you to promote some promotional information about the National Institute of Green Technology, there are demands of the developing countries, and we know and we understand situations better about the country. But proper technology is required in the era of the climate change. If you need some information about this, then please visit our organization so that we can provide information to you. And we can discuss about the circumstances of each country so that the proper technologies can grow further. I'd like to conclude my presentation for now and hope those of you who are sitting here, I hope you can remember, especially Koreans attending this meeting. Appropriate technologies you can use 100 times and you win if appropriate technology is being used. Thank you very much for listening to my presentation. Thank you.
A great talk. I think your translation is much better than ChatGPT. We have a time for one or two questions. Please stay right there. Do you have a question for one or two questions, please?
No?
So I'd like to ask you one question about the vision of this, the 녹색기술연구소. What's the big vision the next 20 years?
Yes. 녹색기술연구소의 비전은 이제 제가 소장 임기가 이제
Policy, vision, I'm gonna, my term is left for 2 years. This is the vision of national technology, of green technology. Establishing fund is not an easy job. There are a lot of funds, but the largest fund will be the World Bank. And also, there are funds in Korea. A lot of funds would have the K, meaning that Korea has donated. So with a lot of K funds, how are we going to use it? We have been thinking about this a lot. So this year, World Bank, Africa Development Bank, GCF, and other international banks, the funds can be connected so that the country can utilize it, provide developing countries a reduction of carbon dioxide reduction, at least providing such vision for at least once this year.
Plenary speaker of the morning session is Professor Sung An from Seoul National University. Professor Sung An is a mechanical engineer with a robust academic and practical background. He has 24 years of experience as a professor and has held positions in Seoul National University, including Department Chair of Mechanical Engineering. His research focuses on smart and appropriate technologies impacting areas like smart material, robotics, and renewable energy. He's recognized with numerous awards, and he has also founded a prominent journal and contributed extensively to academic society. And recently, he was a former president of Appropriate Technology. His educational background includes degrees from the University of Michigan and Stanford University, and his work is highly influential with over 380 publications and 100 registered patents. Please greet him with a big applause.
Thank you for a nice introduction. I'm sorry, I was in other very urgent meeting in the morning, so I was just watching the YouTube of first two presenters. So first two plenary speakers talked about very big picture, and I'm going to talk about more details on appropriate technology. So the title is Appropriate Smart Technology and Its Application. So that's me. More than 10 years ago, I was drinking water in the pond of SNU, and I'm still alive. And then I drank 2 more this year, like that, but still, that means this life straw is good, right? Life straw is only about $20, but if you have this life straw, you can drink any kind of contaminated water that 99.9% of bacteria or microorganism can be filtered. So that's very good for the deprived zone people. But that's $20. $20 seems okay and cheap in Korea, but maybe that's relatively more expensive than a certain region. So appropriate technology has a long history, and then the famous book "Small is Beautiful," written by Dr. Ernst Schumacher, and his book he talked about intermediate technology, and then Dr. Sang-Hyuk Lee talked about the definitions and then the meaning purpose of appropriate technology just now. And the typical appropriate technology is not that smart. That's why I'm talking smart technology today. So this is one of class project in some years ago in my class called the Design for Manufacturing. That's product development course in graduate school of SNU. And we developed this dental drill powered by the toy. So people just jump in the trampoline, then the piston and cylinder generate the compressed air, then we can regulate, and then the actual dentist in remote area can use without any electricity or compressor or any diesel engine. So that's kind of a man-powered appropriate technology case. Then the concept, I'm talking what is smart. See. This is a famous picture of Michelangelo creation of Adam. So nowadays, this is human, this is God, but God tried to be replaceable. God, human tried to replace God. That's kind of a trend, right? It's not going to be successful, but that's trend, and then try to make this device smart. So the material is replaceable by, a lot of technology nowadays, like bioprinting can print organ materials, but it's not living being. So the smartness is embedded by the spirit and mind and intelligence. So intelligence can be another word. And this famous robot nowadays is in the issue. This, if you can click this video. This Optimus from Tesla, they said that they're gonna sell it in $20,000. Right? It's not that cheap now, but then they are planning to sell this in a couple of years. So that means in factory, or not just factory, a lot of working places, the human labor can be replaced by humanoid robotic system. Right? So that's the robotic body, and then intelligence is then the, but spirit is not there. So it's not complete replacement of a human. But that's kind of smartness people are looking for. But that's definitely not appropriate, right? Because the cost is too high. That's about $200,000, right now. That they should reduce 1/10 of the price in very short time. So in terms of sustainability and affordability, that's not that sustainable, appropriate technology. This is a map of the region, and more than 10 years ago, we made this information. This from Google Maps, so that's the information. And using this, we try to develop the renewable energy in that area. That's about 6 kilometer by 2 kilometer, very wide region in Nepal. But those kind of information is available in internet. So we can plan, and then without going there, that's the idea. Then we implement this physical system. So using this water this water is not that much, but that's stored in the middle reservoir in about 100 meter, the head difference from the bottom plant. So that's a small hydro plant we built in Nepal. And if you click the right side video, there's a construction of small wind turbine, 3 kilowatt wind turbine, and then the hydro system is a 20 kilowatt system. So this is a 3 hybrid. We have the solar together, solar, small hydro, and the wind, the hybrid system is generated And then that construction was successfully done. And still, those village people use the power. Right? It's more than 10 years, and it's sustainable. And then, because of region in the semi-tropical region of Nepal, the rain is available, throughout the year, and then even winter there is no snow, ice. So that's very sustainable technology and appropriate technology. But that's not smart. Right? It's just a system we implemented. So today I want to talk about develop building blocks of appropriate smart technologies and sensor appropriate IoT, Internet of Things, and small data, not the big data, and not advanced AI, but small AI. Right? And then demonstrate that in different cases in smart grid, e-mobility, manufacturing, and robotics. So it's not traditional idea of smart technology, but it's not the regular appropriate technology either. So smart sensor, we try to use smart sensor. So what is smart? In my point of view, that's more like multifunctional. So one sensor can do a lot and very cheap. And appropriate IoT. So IoT can be simple, but if you can, we can consider some simpler IoT, and then instead of using big data, reduce the data amount and then reduce the complexity of AI in application. So basic flow is like that. We have a device. It can be power plant, it can be robotics, it can be manufacturing site. So there's physical devices here. Then we can have a sensor attached to the device, so monitor. Then we can have some calculation near the device. Right? So we can reduce the number of data, size, and complexity of calculation because we use very simple computers, cheap computers here, simple algorithm. So remove most of the unnecessary data and only limited data is sent to the server. So store the server in Amazon or Naver, whatever the server system can store very limited data. Then we can have application apps there. So it can give feedback to the device, so device can be smart and then more active. So that's more like research, but then this particle printing process, because using this, we can generate a lot similar technology on resistive-based sensors. So the idea is very simple, about like $500, $500 or $1,000 of a rotary mechanical pump is here. Then we can suck out air in the certain materials combination. So we have a particle. So it's a silver particle or whatever, metal or ceramic particles are located here. Then we can apply compressed air. So that's a positive pressure, negative pressure, combining and control very nicely. Then we can focus the aerosol. So that's a mixture of air and the particle, right? Then we can make deposition at room temperature without any chemical binding. So that's a very cheap process. Then we can make the deposition on various substrates, so polymer, even paper, glass. Then it can be used as a sensor. So this process is cheap, but we can make an effective sensor like here. So this measures strains in 3 axes. So comparing commercial sensor, which costs like 2,000 euro or $2,000 for 3 axes, we can make only $2. Right? $2 sensor can detect the vibration of the manufacturing. So it can measure strain, vibration, and this shows this signal. So during the cutting of a turbine blade that we did in the front of Germany, it can detect the property. So if turbine is cut well, then we don't see this kind of defect shown here. Right? This is defect in the surface, and then actually sensor gives that. So during the cutting, we can stop the process and save time and money. And then we put in the drone, very small drone. So that's representing the idea. It's very light and then simple to attach. So the drone behavior can be monitored. Then we use this microcontroller, very cheap, like some $17, $16 computer is used for the processing the data. If you need AI, then maybe the order become $100 microprocessor. So this is result. With the sensor, we could measure temperature, strain, vibration, moisture. Now working on the light and gas sensor, but this is just very thin film, about size of your thumb nail finger. Right? So then this sensor is very small and the same technology to measure various physical values. So we can put it into simple IoT. So that's entire size is 1/3 of your palm. So you can put this everywhere, right? In the factory, machine, and room. So this compared with the conventional sensor, you have moisture sensor, vibration sensor, thermocouple strain, a lot of wires, volumes, and that's typical technology. But using very simple, appropriate sensor technology, you can make a package, and this includes battery and Wi-Fi together. So that's a complete IoT system. So that's one smart sensor. The other, can you click both of the left side video? This is the more, this one and the bottom one. So that's this deposition on PET film. PET is like a water bottle. You deposit thin layers of a silver and then make a mirror. Then the reaction of the silver layer with the toxic gas, the thickness change, then we see that this NOx, nitrogen oxide, is detected by without any electric system. You can see that by naked eye. And next page, I'm gonna go. Then using this PPG is a sensor. If you find that in your smartwatch, there's like a light device, and also cell phone. It's like a $1 or $2 device. So having this layer and then LED emitted and then the detector, that's a PPG, only $1 sensor. Then you can make this into the NOx gas sensor in complete IoT. So it's a Wi-Fi communication integrated together. So usually, to make this kind of sensor, you have a very bulky, and then you need to increase the temperature up to 300 degrees Celsius. So it's very big to measure the nitrogen oxide, NOx, or SOx. But using this completely different thin film technology, you can make it much cheaper. So the cost of manufacturing is like a cent of this film. So then that's another example of a appropriate smart sensor. Next is a smart grid. At the beginning, I showed this development of renewable energy. And since 2017, funded by National Research Foundation of Korea, Ministry of Science and Technology, we developed a center called ICEAS, Innovative Technology and Energy Center in Tanzania. This local director is Dr. Herbert Lee. He's still there, and after 2017, so many years. The region is called Arusha, so it's near Serengeti and Kilimanjaro. And we are developing the renewable energy related service there. And this is the power plant. It's all solar. So we have 5 systems from the ITEC, and one is IEP that's headed by the Professor Caroline Lee. And then that's 5th solar plant we developed in this year, January. So we have about 10 kilowatt order of small solar plant arrays in this region. Then the problem is monitor and manage, because it's far away. Nepal is only like a 5-6 hour flight, but that's minimum 17 hours to fix to go to this Tanzania. So we tried to develop smart system here. Of course, we started from Nepal. We tried a lot of satellite communication and then Wi-Fi and phone system, but then finally decided to use the simple LoRa and Arduino-based smart meter. So we could measure the power consumption of each house and then power stored, generated in the power plant. But that's very challenging because there was no electricity at all. So all the village, basically there is no electricity, no communication, no Wi-Fi, right? So how to make the kilometer different distance, the communication? So we developed our own wireless communication system and then the one-to-one communication. So that is a real village, one of village here. So the houses are identified in the number, and we developed this Arduino-based sensor. So simple Arduino board and the LoRa chip, and then mechanical relay. And this is a virtual world. We can see this in computer. So we can see each house's power consumption, and we can see this power generated by the solar plant remotely. It's virtual space. So it can be monitored in the operator's computer in the plant, or you can see that in the school in Tanzania, or even you can see that from Korea. So that's called digital twin. And this is e-bike, e-mobility we are developing. And interestingly, the battery is the seed lead acid. It's not lithium polymer, lithium ion. This battery you can buy in any solar shop. Just a small, lead acid battery. We don't use in Korea because it's not good. It's used for the car, but then because that's very cheap and available, that's the technology we use for this electric motor bike. So actually this work with this Arusha Technical College and ITech and SNU. So we integrated the parts, and then students make the welding and assembly together. So finally, this is Regional Commissioner Honorable Mongella in the yellow shirt. So he's kind of taking the media shot of this Seoul National University bike. So that's me, and that's Professor Caroline Lee, that's Dr. Herb Lee, that's Director of E3 Empower, Director Ji-young Lee. And then our students are here. So that really works, right? And then we tested this with different battery. There's sealed lead acid battery, there's supercapacitor battery. Now we are testing lithium ion battery, or about 3 kilowatt hour capacity. So this is a road test in the highway, and then we are trying to connect that to the smart grid. So it's not just bike. It has a smart device in the back right here. Right? That's last year I was riding in the ATC campus. So this information of the battery consumption, location, speed of the bike, e-bike, is integrated together with the power generating store data of the village, right? In 2D communication. If that's close, within 10 kilometers, then we can use a LoRa. That's a 433 megahertz radio frequency. It doesn't require any of other device. We can communicate one-to-one. So the goal is like this. If you are in somewhere in Tanzania, then there is no electricity around at all, right? That's the situation. Then we have 3 villages installed with the solar plant. Then the smart device is all integrated together, very cheap, Arduino based, right? Then if you make a user interface, and then it can tell which village is the best in terms of distance to travel, and then how much cost of the electricity, whether electricity even available or not, because this some of village is rainy day, you don't get any of electricity in some village. So if you go there, you're dead. Your bike is dead. You cannot go until the sunny day. So these kind of constraints are provided, and then this is one of presentation today. My student, Hyun-soo Kim, is giving this result. So the communication can be 2G, it's like a SMS message, and then the LoRa radio frequency, our own system, is communicating house to the center. Then we have user interface database. So this is very complicated, but it's very simple smart device integrated together. So look at this user interface. That's kind of a test. The map, the Google map there, the data is provided. So the driver can see real time where to go, how much far to go. And then that's much fast forwarded video. This is a real video, much slower. And then driver is arriving the solar plant, one of the plant. And then charge the bike, and then he can go to other village for whatever, delivery or transportation. So the goal is independent energy. So villagers is independent from government, right? It's a good idea. They generate their own energy from solar energy, and then transportation, they don't have to depend on petroleum. They have their own battery, the transportation system. And then that's all integrate and efficient because they're talking together, each other. Right? Let's see. Last issue, manufacturing. So we call smart factory or smart manufacturing. So idea is getting some information from the sensor, then you can make this improved. So how to improve? We try to make these issues essential, affordable, simple, interoperable. That's specifically for the factory because many of the industrial machine is not interoperable. They purchase a legacy machine and new machine. They don't talk each other. So how to make them communicate each other is one issue. So one is using power-based IoT because every machine in the factory, they consume electricity. So this is a uniform, simple, and interoperable technology. We measure the power profile of each hardware, the same as we measure the smart grid data of each house, exactly same technology, Arduino, and then the communication. But the thing is how to manipulate this or interpret this power data into something. So usually that's a productivity. Can you click this video? That's one of the projects we did with Hojon and Mpapa. This 5,000 people in Indonesia, a sewing machine. So we want to know what is real-time production rate, the number. And Professor Thur, we work together. So this is more like an industrial engineering approach. But so far, nobody actually successfully get this data because this sensor is expensive. Sewing machine is only $500. So sensor is $5,000. Nobody use, right? And then there's 5,000 sewing machine. It's impossible to measure. So we use very simple power meter in each sewing machine and measure this, and then this data can be converted to productivity. So this is 1 or 0. That's 1 means it made 1 process. And then this performance of the workers is manages, and then actually entire algorithm we use is very simple. So compared with this CNN, very popular, the deep learning mechanism algorithm, using statistic-based algorithm, we can do the computation in 3 seconds of 1 day of workers, right? So that's very fast. 5,000 doesn't make a big difference. But another issue is that the cost of the hardware, if you use a statistic-based algorithm, you can use just $1,000 regular CPU computer for 1,000 sewing machine monitoring. But if you use CNN, that's deep learning, so you need to buy NVIDIA GPU, that's like 5,000 for 5 sewing machines. That's impossible to monitor using the deep learning algorithm. So that's what I said, this appropriate algorithm. You have an appropriate algorithm, then you save a lot of money, but it's not just money. It was impossible with conventional technology, but using appropriate technology, you can make it happen. So even that can improve the optimization of the sewing factory design, because we got the data, then we know where is the problem, bottleneck site of this line. So we can put more people in the bottleneck site. So if you do that, finally, by the calculation, we can improve productivity 70%, by knowing this. And this is the smart lab with interoperable machine. So I make fun of my graduate student. I want to get rid of all graduate students in my lab, right? So I want to ask a robotic system to do all the simple experiment. So this is the 3D printing of various layers, so all different mechanical property. then this cobot with automotive mobile robot integrate together is kind of a master of this scene. And these are all integrated. But at the beginning, this printer is only like $200. It doesn't have any interface with other outside. But we could make very simple interface with this and then right side material testing machine, MTS or Instron. So this robot is ordering to the printer to make the specimen. And after making it, then this robot is taking out and rotate, flip, manipulate, then put it into the material testing machine and getting the stress strain raw data, right? Once you get it, you can send to the outside. So this is one approach we tried from Arusha Technical College in Tanzania, access to our lab and utilize our facility without paying. Of course, they can pay. So in this scenario, if we have a very good facility, you can share the facility with outside, very far away. Even internet is not available, that's okay. You know, usually robotic is controlled real time, but this is more high level language, you can say. So internet is discontinuous, still you can use this system. So last issue is the robotic. I talked about the Optimus of Tesla, but I talked to my student. That's the goal. It's like a $7,000 price to make a two-arm autonomous robot, right? And then it can go step up and down. That's the requirement. So student made a two, and then this is integrated with the small large language model. So large language model is ChatGPT, and small large language model is available open source, very small size of the computation is needed. So if I say, and then laying in my sofa, talk to the robot, get the water from my refrigerator, then you go, and then get my newspaper, then you can go, and then, that's my idea. But then, actually they are making it, so a lot of technologies are there, but today, the students gonna present these three technologies in other presentation. So can you click this video here? So actually getting water bottle idea is a language model. So I can speak in English, Korean, Chinese, and French, any language they understand. And then it already understand what is water, right? So if I say water or banana, no, I don't have to teach. The model already understand. So it's very easy to implement. Then this position is connected by the simple paper-based marker. And then this arm, you can click this and this too. So the motor is expensive, and we are trying to soft robotic system. So without motors, just 3D printed arm can get this pipe. So, and then put it in the upper arm of the robot. So, you know, it doesn't require much of complex mechanism. So $1,000, if you like to buy, let me know. And there's a step up and step down. Yeah, so summary. I showed these building blocks of appropriate smart technology using smart sensor, appropriate IoT, small data, small AI, and grid, mobility, manufacturing robotics are presented. And there are a lot of issues to solve on this affordability. You know, cost issue is very big still, and sustainability. Is economic system and technology should integrate together to provide the sustainability and the human-centric design, because you know any technology human developed, like at the beginning, the Adam, so creation of Adam, people are trying to attack God's world, and then sometimes it's dangerous, right? So we need to have more like a safe technology. Otherwise, it can be very dangerous, like a nuclear or whatever the power. Okay, thank you very much for your kind attention. Thank you.
Thank you for your nice. Any question? One question? Okay.
Oh yeah, Professor 김인원. 네네. 네.
예, 기술적인 가능성이나 모든 거에 대해서는 다 봤는데
We've taken a look at technologies. But for sustainable development, I think the connection between the technology and local community is important. How long have you been preparing for this?
Sustainability, which should be linked to the business and economy. So one case is donation, right? This ODA model I showed in the renewable power plant in Nepal and Tanzania. That's a donation model. So if you have a certain effort, then it can be sustained maybe like 10 years or 20 years. But that's exactly the good issue on the sustainability in business. So like a robotic system, e-mobility, donation model is not sustainable. Especially in Korea, Professor Sang-hyuk Lee mentioned the funding, right? Its funding is 3 year, 5 year, that's it. Then after that, nobody cares. Then this entire system is gone. So we need to make the business. So this student in our laboratory, they try to make a startup business, like so the e-mobility and the robotic system and the power plant. And then one of the electric power-based model and technology is used for the startup of one of my student group. They use that for electric car charging system, right? So monitoring and then control the power distribution. So one charging station can distribute many cars, something like that. So that's what we are trying to develop the small startup from our technology. This is a trial. We don't have a good result yet. Okay.
Okay, thank you. Thank you for your nice talk.
Thank you so much.
Plenary speakers for this morning for your magnificent talk. This is the end of our morning session. For one thing, we have a translation receiver on your desk. Please leave it on your desk before you move. 이거 통역 번역기 있는데 요거를 반드시 자리에 놓고 이동하시고요.
Please return your receiver to its original place.
B1 floor in Rakgujang for lunch, and then we'll have a session. We'll start the session again at 1 p.m. Thank you. I hope that you would have you would also participate again. Every one of you participate again. We have 3 sessions provided. We have a much more rich programs. Thank you all for attending. Thank you. 리시버 꼭 내려놔 주시고 가세요.